Do you worry how secure your client and server connections really are? Each TLS protocol update fixes vulnerabilities and supports stronger ciphers. But the version used is only as strong as what's negotiated. Modern browsers should be using TLS 1.2 or 1.3. But what about software agents or IoT devices? Don't forget the servers either. Has SSL and TLS 1.0 been disabled? Would you like to learn how to check who would be affected before flipping the disable switch? In this video, we're going to see how to capture TLS packets with my Endace Probe. Then we'll use Wireshark to look into the client and server hello packets to see what's really happening. Hellos in the TLS handshake are clear text, so we don't even have to worry about decryption. Let's dive in. We're going to start by capturing the packets, because server logs, event logs, and monitoring systems don't necessarily track the TLS hello fields that we need. If I use a capture filter, I'll get more of the packets I need by filtering out what I don't. Besides, smaller datasets are always faster to analyze. On my Endace Probe, I'm going to come over to Resource, and then Filters, and TCP dump syntax filter. That's the same syntax that Wireshark uses for capture filters. I already have one configured called port 443, which is TCP port 443. If I wanted additional non-standard ports, the syntax would be TCP port 443 or TCP port 8443. If I wanted UDP port 443 also, it would just be port 443, and that would give us both TCP and UDP. But UDP port 443 is the protocol quick, and that's a whole nother video. I'm filtering out the MAC address of my Endace Probe. That way it's not a part of the capture and I can focus on my production traffic. Now if I come over here to data pipe, you can see that I applied my port 443 filter to the capture. We need a decent sample of data, say a full workday. So let's let this run. Almost a day of packet capture later, and we're ready to analyze. If you have limited packet capture storage, capturing only the traffic you're interested in will make for a smaller file. My Endace Probe has 3.8 terabytes of first-in, first-out storage, but you see I only used 87 gigs for this test. Now that I'm focused on just the port 443 traffic, I can go into Endace Vision and my TLS audit investigation. I see traffic going to Microsoft OneDrive is my top application, and that's to be expected. But gracious, look how much TikTok traffic there is. I want to view these packets in Wireshark so I can go deep into the TLS headers. Endace Vision is a fast graphical display of the recorded packets, but its search engine only indexes certain fields in the headers. There's always that darn balance between speed and complexity. We'll use Wireshark to look at the fields in the client and server hello packets. I'll extract out just these 10 workday hours instead of downloading the entire capture. I don't want to make Wireshark choke by trying to load the entire file into it. We only need the client and server hellos. We can save a ton of time by using a read filter. I'll type in tls.handshake.type and then use the in operator so I can enter a list, and then 1 space 2 in curly brackets. This will give me just packets with the handshake type fields for client and server, but no certificate packets, for example. Now only the packets we're interested in are loaded into Wireshark's memory versus the entire 48 gigs or so that we got by slicing to the 10-hour workday. I'm switching to my TLS profile. It has time-saving protocol settings, columns, and filters. I'll put a download link into the description for you. The server can only go as high in version as what the client supports. So let's check the clients first. These buttons I've added will filter to just client hellos for each of the different version groups and are saved in that profile file. I'm going to come down to the fields in the packet details section, and here you can see in the protocol version field what is the minimum capability that the client can support. And then a little bit further down is the client version field, and that's the maximum version that they can support. Some IP addresses show up more than once. Having the server name column showing the server they were connecting to will help me track which servers have connection attempts that were looking for those older TLS versions. That server name is what would have shown up in their address bar. Clients offering an older version could be due to a cookie from the last conversation with that server, or it could be a software agent making a request rather than a browser. Since the server is really making the version determination, we want to look at the servers next. The server selects the highest TLS version that both it and the client supports. What would happen if the server refuses the highest version that the client supports? Well, they would just send a TCP fin for finish, and an error message would be displayed in the browser. Here's where you would have more control in a production environment by disabling the older, slower, less secure versions of TLS. Once I filter for which servers are using TLS 1.1 or older, I can go to Statistics and Endpoints to get a unique list. Don't forget to tick the Limit to Display Filter checkbox so the list is updated from every IP address in the trace file to just those filtered to TLS 1.1 or older. We can use this for any of the filters we apply. We can send a list to the server team by exporting it to a CSV file. We could repeat the process for TLS 1.2 and 1.3. Usually the ultimate goal is to use TLS 1.3 whenever possible, because it only requires 2 packets in the handshake versus 4, has eliminated support for vulnerable ciphers, and uses session-specific keys. These features make it more secure than TLS 1.2. But some middle boxes can't handle the high session key count. So in that case, 1.2 might still serve you best. Flipping back and forth between the filters and endpoints makes it easy to see what everyone is really doing. Now I know who's using the older, less secure versions of TLS. I have some client updates to do. And now you know how to pull a list of servers and which subnets are talking to them. Your team can warn those specific user groups about updates rather than sending out a blanket company-wide email. We were able to capture a big enough sample to do a more complete audit thanks to my Endace Probe, and parse it pretty quickly in Wireshark thanks to filters and statistics. Using this approach, we can identify specific hosts that make your environment less secure. Do you have a packet mystery you'd like me to solve? Let me know about it in the comments below, and maybe it will inspire the next chapter of Packet Detectives.